In this video, we're going to talk about modeling geometric sequences. We're given the real-world problem. The value of a rare coin is $450. The value will double every year. Write an equation to find the value of the coin based on the number of years you keep it. So, based off our initial situation, we can write an explicit rule of the situation that models a geometric sequence, because we have an initial value that's doubling every year. So we're not adding an amount, we're going to multiply each year. So our explicit rule for this is if you have the sequence g sub n, so to find what it is next year will be equal to the initial value, so 450, multiply by our constant difference. Since we're doubling, we're multiplying each term by 2. So our constant difference here is 2 raised to n minus 1. So this is how to express it in the form of a geometric sequence. However, it's asking us to write an equation. So if we wanted to express this algebraically, we could write it in terms of x and y. Alright? If we look at our explicit rule, that g sub n represents the value after n minus 1 years. And then n minus 1 represents the value as the number of years. So if I wanted to write an algebraic equation, I could replace the value after n minus 1, so the value of the coin, with the variable y, and then rewrite my initial value and constant difference, and instead of using n minus 1 for the number of years, I can use the variable x. This is called an exponential equation. And we're going to use exponential equations throughout the rest of this unit in modeling these types of situations. Now, another situation that would use an exponential equation is exponential growth and decay. And the general form of an exponential growth or decay problem is A equals a sub 0, which is a sub 0 is the initial value, times 1 plus r raised to t. This is where r is the rate of growth or decay, which is represented as a decimal, and t represents the number of years. So if I looked at an example, B invested $15,000 at a rate of 8% per year. If I wanted to write an equation that modeled this situation, I would say A, or the value of next year, however many years is passing, equals to our initial value, so her initial investment of $15,000, times 1 plus her rate of 8%. Now remember, when we have a percent, we can represent it as a decimal, saying by moving the decimal of the over here by the 8 to the left 2 places. And so my rate as a decimal is 0.08 raised to t. And I could simplify this down further by simplifying what's in parentheses to say 1.08 raised to a t. And this would be an equation that models this situation. It's important to remember the context of your problem. So here, when we're investing money, we're hoping that money will grow. So it's a rate that's going to be adding to it. However, when we do an exponential decay, my rate will be negative. So when it's decay, we have a negative rate where we will be subtracting from 1. And so it's important to remember that while we're modeling these types of situations using exponential equations.